Soil washing, a technology at work to make a difference in our environment. A Russian and American team committed to developing that technology for U.S. industry. This is just one project in the Department of Energy's Initiatives for Proliferation Prevention (IPP) program. The project team leader is a small American company, SoilTech Environmental Systems. SoilTech is leveraging corporate research and development money to access available Russian technical talent. Russian scientists are doing challenging R&D work, and their institute stands to share in SoilTech's commercial success. The Department of Energy in Oak Ridge is using its technology transfer experience to make this project work. The DOE stands to gain by fostering development of soil washing technology, which can be utilized in DOE environmental cleanup projects. Soil washing, in its most simple form, is just like washing clothes. Agitation in water containing surfactants cleans soil particles too. This basic process works well for soils contaminated with oily organics. But contaminants may be chemically bound to the soil, or soil may be mixed with contaminant particles like uranium, mercury, thorium, or plutonium. These problems require a more complex washing system, which may include a process to sort different types of particles by their size, or chemicals may be mixed with the wash water to dissolve contaminants. Soil washing is a versatile technology. The process can be tailored to the contamination problems of a specific site, so that soil washing can clean up this industrial site in Alberta, a refinery site in Peru, oil-contaminated Louisiana red clay, or Department of Energy sites that contain an estimated 60 million cubic yards of radioactively contaminated soils at locations such as the Nevada Test Site, Sandia National Laboratory in New Mexico, Idaho National Engineering Laboratory near Idaho Falls, or industrial sites like Maywood, New Jersey. The modified SoilTech system will handle up to 40 tons of soil per hour, which means large sites can be remediated quickly and effectively. The SoilTech concept grew out of oil field experience in Louisiana, where similar equipment was used to recover oil from drilling mud. SoilTech built its first unit in 1992 and is now successfully using field units to clean up petroleum contamination and industrial inorganic salt spills. SoilTech wants to put its system to work cleaning up radioactive soil. They estimate that soil washing costs could be less than 1/4 that of competing remediation technologies, and DOE's Office of Technology Development is counting on soil washing to produce major taxpayer savings. But adapting the current 40-ton per hour soil washing system to treat a radioactively contaminated site can't be done in the field, and SoilTech, a small company, does not have any laboratory facilities to do the testing and guide the necessary modification process. However, Section 575 of the U.S. Foreign Appropriations Act of 1994 provides cost-sharing support for joint cooperation between the DOE laboratories, Russian institutes, and U.S. industry to work on projects which benefit all three parties. SoilTech asked for this type of help from the DOE IPP program to modify the design of its machine so that it could also be used to clean soil contaminated with radioactive particles. The project request was approved. The Buchvar Institute in Moscow is the Russian partner in this project. 1996 is the institute's 50th anniversary. This premier institute formerly produced plutonium for nuclear weapons and fuel for nuclear reactors. With the end of the Cold War, it is turning its attention to the Cold War legacy by developing environmental cleanup and non-proliferation technologies. The SoilTech commercial process was duplicated on a small scale in the Buchvar laboratories to facilitate equipment design, testing, and modification. This small system can process 10 kilograms of soil per hour. The system was officially christened by SoilTech representatives, Buchvar staff, and the U.S. Department of Energy project manager in a recent meeting at the Buchvar Institute in Moscow. These are some of Buchvar's most capable scientists and engineers, former weapons technologists, now members of the team working on SoilTech's behalf. Dr. Vladimir Lubimov earned USSR Gold and Bronze Achievement Awards and has 8 inventions in plutonium processing. He is now developing environmental technology and waste treatment options for this project. Dr. Nikolay Naumenko is the Buchvar project leader. He has designed processing equipment for plutonium recovery and has over 30 technical papers and 6 inventions. He is coordinating all design and testing on this project. Dr. Vladimir Sherbatich was responsible for the automation of plutonium processes using pulsed column technology. He is well known internationally for both his publications and inventions. He is now one of the key engineers in charge of the team, which is working to automate the soil washing process. Dr. Vladimir Andrinov is a key member of the Process Automation Department. Dr. Anatoly Polyakov, the Institute Deputy Director and head of the Radiochemistry Department, takes us through the operation of the lab system. The soil is fed into the slurry preparation device and water is added. This device separates the soil particles and suspends them in water while expelling debris such as rocks. The device extends down to the floor below. The suspended soil is transferred to an agitating tank, then transferred to the first vibrating screen. Large soil particles fall from the front of the screen, while smaller particles are washed through it and flow to the second screen. Intermediate-sized particles are collected here, and smaller particles are transferred to a hydrocyclone for further separation. The ultrafine particles are fed to a tank where flocculant chemicals are added, and then to a centrifuge to remove the remaining particles from the wash water. Vibroscreens and hydrocyclones are adjusted for the best separation of contaminant and clean particles. The adjustment is achieved by using different screen sizes and by adjusting the fluid flow rate through the hydrocyclone. Flow through the system is measured with non-contact flow meters. Equipment performance is monitored on a control panel. The entire process can be manually controlled or remotely controlled by computer. Here, Dr. Sherbatich demonstrates the new software he's developing. These computers were sent to Buchvar this year by SoilTech as part of their project cost share commitment. SoilTech is already preparing for similar automation of the commercial units. Results from the Russian small-scale tests will improve the commercial system design in ways which will be important for cleanup of soil from both radioactive and hazardous material contamination. The lab system is rugged and completely enclosed, so radioactive materials can be safely handled and adverse field conditions will not affect operations. Perhaps the most important development so far has been the automated control system. Process parameters can be maintained at their optimum values based on the cleaning effectiveness and radiological control. The next phase of this project involves laboratory testing of soil from the Bryansk region of Russia using the Buchvar system. The Bryansk region was contaminated by the 1986 Chernobyl nuclear reactor accident. Soil from this region was sampled and tested by Buchvar. Both soil characteristics and contamination levels are suitable for soil washing. Site and local infrastructure makes the Bryansk region a good candidate for later field testing. This project is an important part of a bigger program that brings American and Russian scientists and engineers, once Cold War enemies, together to work as partners, combining their knowledge and abilities not only to benefit American industry, but to help make the world a cleaner and safer place.